All right, let's jump right in. We're tackling SAT geometry, but here's the deal. I want you to completely forget everything you think you know about it. Seriously, forget all those painful proofs from high school, forget the abstract shapes floating in space. We're gonna reframe this whole thing. It's not a math problem, it's a puzzle. It's a game with a secret set of rules, and once you know them, well, you just can't lose.
I mean, really let that sink in for a second. What if the stuff that looks the hardest, those circle problems, those coordinate grids, what if that was actually the easiest part of the test? Like a cheat code hidden in plain sight. What if it's not a trap, but a massive opportunity just sitting there waiting for you to grab it? Well, guess what? That's exactly what we're going to do right now.
And that's the absolute truth of it. The folks who make the SAT, they want this stuff to look intimidating. They want you to see a circle sitting on a graph and feel that little knot of panic in your stomach. But here's the secret. Behind that big, scary curtain, it's just a tiny set of rules. And once you see them, the whole illusion just falls apart.
Okay, so where do we even begin? We start with the SAT's all-time favorite shape, and I mean they are obsessed with it, the circle. And you might be asking, why? Why the circle? Well, it's because circles are, weirdly enough, kind of polite. They're super predictable. They play by the same rules every single time, no exceptions.
Look, pretty much every single circle problem they can throw at you boils down to these three things. You got the center, right? That's your home base. Then there's the radius, r, that's just the distance from the center to any point on the edge. And the diameter. That's just a line that goes all the way across, straight through the center. But the key thing to lock in your brain is this. If you don't know where the center is, you're lost. Everything, and I mean everything, starts at the center.
And here it is. This is one of the oldest, simplest tricks in the SAT playbook. It's brilliant, really. They know that all the important circle formulas, like for area and circumference, they all use the radius, right? R. So what's the trap? They'll just casually mention that the diameter is 10. They're betting you're in a rush, you'll see the number 10, and you'll just plug it straight into your formula. See, it's not a test of complex math. It's a test to see if you're paying attention. All right, let's talk about those scary-sounding words, arc length and sector area. When you see those, I know the temptation is to just shut down. But don't. From this moment on, these are not math problems. They are pizza problems. Seriously. An arc? That's just the crust of one slice of pizza. A sector? That's the whole slice itself, cheese and all. And how do you know how much pizza you have? You just look at the angle in the middle. It's just a fraction of the whole pie. That's it. You know, the SAT is full of these little hidden clues, just sitting there in plain sight. Take this one, for example. Whenever you see a radius touch a tangent line, that's a line that just skims the edge of the circle, you know with absolute 100% certainty that it forms a perfect 90-degree angle. And what does a 90-degree angle mean? It means you've got a right triangle. This isn't just some random fact. It's a giant flashing neon sign from the test makers, practically screaming, hey, use the Pythagorean theorem right here.
Okay, and then there's this beast. This is what happens when a circle gets put on a map. I know, the equation looks like a mess, but trust me, it's not. Think of it like a filing system for the circle's info. The H and K, that's just the X and Y address of the center. And that number on the other side, that's the radius squared. So your job isn't to build this crazy equation. Your job is to just read it. They give you the equation, you just pull out the information. It's basically a matching game. All right, that brings us to our second big key. This is where we take all those shapes that were just kind of floating around, circles, triangles, lines, and we nail them down. We give them a home and address on the coordinate plane. It's like giving them a GPS location, because from now on, we're not guessing anymore. We're measuring.
And here it is, the dreaded distance formula. I'm pretty sure this is the #1 formula that people memorize the night before a test and then completely forget the second they walk out. And yeah, it looks clunky. Let's be honest, it is clunky. But here's the good news. The SAT doesn't really care if you can write this out from memory. What they do care about is whether you get what it's actually doing.
And this is the big reveal, the aha moment. That whole complicated thing, it's just the Pythagorean theorem wearing a fancy disguise. That's it. A squared plus B squared equals C squared. The distance between any 2 points is just the long side, the hypotenuse of a right triangle that you can literally draw on the graph. Once you see that, you can pretty much just throw the formula away. Same deal with the midpoint formula. It looks like math, but it's just common sense. Think about it. How do you find the middle of any 2 numbers? You average them, right? Well, that's all this is. You just average the 2 x coordinates, then you average the 2 y coordinates, and boom, you've got the exact center point. And trust me, the SAT loves to sneak this in when they ask for the center of a circle or the middle of a line segment. Now, this is just beautiful, simple logic. You don't even need to draw a graph for this. If 2 lines are parallel, what does that mean? It means they're running in the exact same direction, forever. So their slopes have to be exactly the same. They're climbing the same hill. And if they're perpendicular, making a perfect T shape, their slopes are what we call negative reciprocals. It's a fancy term, but it just means they're exact opposites. If one slope is 2, the other is negative 1/2. Simple rule, but it solves so many problems. Okay,